number 3. So number 3, when I look at 32 and I look at 2, I notice that 32 and 2 are not on this list of perfect squares. That doesn't mean I can't factor it. I choose the smaller of the two values, which is 2, and I identify all the numbers that divide into 2. And then I grab the calculator. Yes, you will be able to use a calculator, and you also need to show your work. And I'm going to now take this, and I'm going to start by dividing by 2. So 32 divided by 2. I get an answer of 16. Well, I know 2 divided by 2 also gives me a nice pretty answer. So I know I can divide by 2. Let's factor out a 2. 16x squared minus 1y to the 4th. How was I able to achieve what's inside the parentheses? 32 divided by 2. Negative 2 divided by 2. And then I brought down the variables and exponents and the sign in between. Now I go back and I look at that list and I have 16 and 1. 16 and 1 are both part of the perfect squares. So 16 breaks into 4 and 4. 1 breaks into 1 and 1. This is divisible by 2, so I take 2 and divide it by 2. And 4 is divisible by 2. I take 4 and divide it by 2. And because I have subtraction, I can keep going. So I'm going to make 2 parentheses. In the fronts here, I'm going to identify what came from the front. The 4 and the x's come from the front. So 4 and x's come from the front. In the back would be the 1's and the y's. So in back would be 1's and y's. It does not matter which one is addition and which one is subtraction. Now, here's the part where a lot of people get a point taken off. What am I forgetting to do? Bring down the 2. This expression is equivalent to this original expression. It's just rewritten in factored form. Please go on your review, put a circle if you feel like you need to review number 3, put an X if you feel really confident. If you are live with me, I'm going to go back and do number 1 and 2 because I messed up with filming. So please go back, give me a brief second, look at number 4 while you wait for me. 25, x to the 4th minus 64, y to the 10th, and 12x squared plus 75. So 25 and 64 are both on that perfect square list. 25 breaks into 5 and 5. 64 breaks into 8 and 8. I can divide each of these exponents by 2. When I divide 4 by 2, and when I divide by 2. Now, I have to have subtraction in between when we are breaking up the binomials. So now I make my parentheses. And I need to figure out what goes in place here. The 5's and the x squareds come from the front. In back would be the 8's and the y to the 5th. 1 is addition, 1 is subtraction. Now, we never factored anything out, so there's nothing that has to go in front. Let's go ahead and look at example number 2 on the factoring review. Okay, 12 and 75. Here is something that I think will probably catch you off guard. 12 and 75 are not on this list, but that doesn't mean I still can't break it apart. So I go with the smaller of the two numbers, which is 12, and I identify what numbers divide into 12. 1, 2, 3, 4, 6, and 12. Then I grab the calculator, and I'm going to go one by one through this list. So I'm going to go 12 divided by 12. That works. But when I take 75 and divide it by 12, we see that I don't get a whole number. I take 75 and divide it by 6. Again, there's no whole number. 75 divided by 4 does not work. 75 divided by 3 is the first number in this list. That works. So I know that I can divide out or factor out a 3 out of both terms. I'm going to start by doing that. Factoring out a 3, 12 divided by 3 is 4. 75 divided by 3 is 25. And in this case, there's nothing more I can do. Now, why can't I go any further? Yes, 4 breaks into 2 and 2, 25 breaks into 5 and 5, and this is divisible by 2, but what's holding me back from going further is that I have an addition sign instead of a subtraction sign. So for example number 2 on the review, this is as far as I can go. Let's go and look right now at number 4. Turn to your partner while I write down number 4. So I'm going to go back to that list and I'm going to look. Yes, 4 is on this list. Yes, 9 is on this list. Wonderful. Yes, this is divisible by 2. Great. But because I have addition instead of subtraction, there's nothing I can do. I can't even factor out a value other than 1, so there's nothing I can do. I would write not factorable. Not factorable. So although this is not on your review, it is a problem like you're going to see on your upcoming test. So I'm looking at 27 and 147. 27, that's not here. 147, that's not here either. So what am I going to do? I choose the smaller of the two numbers, which is 27, and I want to identify what divides into 27 nicely. And I want to factor out, if possible, the largest number there. So here we go. I'm going to take this list. I'm going to attack it with 147. So I'm typing in 147, and I'm going to start by dividing by 27. That does not work. It's not a whole number. 147 divided by 9. That does not work. 147 divided by 3. Ooh, that does work. I can factor out a 3 out of both. Let's do that. Factoring out of 3, 27 divided by 3 is 9. Bring everything else down, bring everything else down. 147 divided by 3 is 49. Now, I'm looking at just this part. Is 9 and 49 on this list? 9 and 49 are both on this list. That helps me. 9 breaks into 3 and 3. 49 breaks into 7 and 7. This is divisible. This is divisible by 2, so it breaks into 8 and 8. I should put 8 up here. Okay, this is divisible by 2. It breaks into 5 and 5. And I have subtraction, like everything is working great. Okay, so then I have to ask myself, what comes from the front? The 3 and the x's come from the front. And the 7s and the y's come from the back. One of them is positive, one of them is negative. I turn this in and my teacher says, I'm sorry, I cannot give you all the points. Turn to your partner, what did I not do? (98y to the 10th minus 18x to the 8th, or to the 9th. And I look on the list for 98 and 18. 98 is not here, 18 is not here. So I'm asking myself, what do I have to do? What do I have to do? So I'm going to grab a calculator, and I'm going to start dividing by 18. So 98 divided by 18, I'll move it into view so you guys can see. That doesn't work. 98 divided by 9, that doesn't work. Divided by 6, divided by 3, none of that works. 98 divided by 3, I'm sorry, did I miss one? Divided by 2, oh, I typed it in wrong. Divided by 2 works, okay. So they're both even. I can factor out a 2. Let's start with that. So 98 divided by 2 is 49. 18 divided by 2 is 9. And then I stop. Yes, I know this breaks into 7, 7. Yes, this breaks into 3 and 3. Yes, I have subtraction in the middle. Yes, this is divisible by 2, but can I take 9 and divide it by 2 and get a nice whole number? The only thing I can do is factor out a 2. That's it. So how would I write my final answer if this was it? I would write it just like this. There's nothing more I can do. All right, so we are looking right now at examples 5 and 6 that are on the review. If you don't see a number in front, it is a 1. So I'm going to try to identify 1 and 125, and I'm now going to the cubes. 1 is there, and 125 there.
It's not 125, it's just 1 for 5.
What?
For 5, it's just x cubed plus 1 for number 5.
Really?
Yeah. The number 6 is 125.
You know what?
Negative 6. Like,
I'm going to bump this up. You know what I was doing? I was showing you the test. You guys never wrote those down. Woo! I'm good to go. And I'm never going to show you this video. All right, you guys ready? Good thing Katie caught me on that. Okay, are you guys ready? I was like, Katie, I'm looking right at it. No, that was the test I was looking at. All right, so the number in front is a 1. 1 is on the list right here. 1 is 1 times 1 times 1. So I'm going to break that apart. 1, 1, 1. 1, 1, 1. This is divisible by 3. And now, whenever we are working with cubes and we are factoring, what we need to do is make 2 places to put our terms in the first parenthesis and 3 in the second parenthesis. That only happens when we're working with cubes. So how do I know what to bring down? Well, I'm going to start with the signs. This is always positive, no matter what problem that we are factoring, and it's factorable with cubes. For this problem, since we have a sign in between that starts with addition, then the first parenthesis has addition, and this other missing sign will be the opposite of the first. In the front place, I'm going to take one item from the front, so a 1 and an X because they both came from the front. In the back, I'm going to grab one item from the back. I'm going to go to the front of the second parentheses, and I'm going to take the remaining 4 items. I'm going to multiply. 1 times 1 is 1. X times X is X squared. In the far back, 1 times 1 is 1. Now, how do I know what to fill in with this missing piece? We already know the sign, so don't worry about the sign. We're just going to multiply the first and the second. 1 times 1 is 1, and we have an X. This is fully factored. As a reminder, when you factor, it's just an equivalent way to rewrite the initial expression. Okay, let's go on to the next one. So making sure that I give you the right problem, let's do this one. 125 x to the third minus 64. That's right. Correct, Katie?
Yes.
Okay. All right, here we go. So 125 is on the list. It's 5, 5, and 5. And 64 is on the list. It is 4, 4, and 4. This is divisible by 3, so I can keep going. Can you do me a favor? Not everybody feels comfortable with this. I know that from walking around and kind of seeing what you've done. Can you do me a favor, turning to your partner? What signs go into these 3 places? Ready, get set, and go. What signs go into these 3 places?
Yeah.
Okay, I'm taking one item from the front, which is a 5 and an X, and I'm crossing it out. I'm taking one item from the back, which is a 4, and I'm crossing it out. Now, here's where the confusion starts. A lot of kids do pretty well with that front parenthesis. But in this position, a lot of times kids put 10x squared because 2 5s is 10 and then there's an x squared. But that's not right. What should be this number? Yes, there's 2 5s, but instead of adding them, what should I do? So 25x squared. 25x squared, that goes in front. In the back, I have 2 4s. 4 times 4 is 16. So I've used those 2. I've used all 4 of these terms. And now I need to figure out this missing term. So how do I do that? What I'm going to do is not worry about the sign because I know it's addition. I multiply the front and the back. 4 times 5 is 20 with an x. 20x. This problem is done. How many by a raise of hands can give me a thumbs up to the side or down based on if you're going to take a test on one of these? You feel confident 100%? Not quite 100%. Thumbs down as I'm feeling pretty confused. Go. Where are you right now? Okay, ready? I'm going to make up a problem for you. Here we go. Please do this problem. 3x cubed. 3x cubed. Please write that down. Minus 24. I'm going to have you working it with your partner. You have 90 seconds. Ready, begin. All right, so in this problem, 3 and 24 are not perfect cubes, but I can factor out a 3. I'm going to go quick here. 3 divided by 3 is 1. 24 divided by 3 is 8. 1 and 8 are both on this list. 1 and 8 are both on this list. There's a 1 and there's an 8. So just to speed this up for you, 1, 1, 1, x, 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 2, 2, 2. I need to fill in these positions. This is always positive. Since I was provided negative, it's negative here, and it's opposite, which would be positive in the next. 1 and x are in front, 2's in back. 1x, 2. 1 times 1 is 1 with an x squared. 2 times 2 is 4. Now in this position, I multiply the front and the back to end up with 2x. Don't forget about the 3 out front. First thing we're going to do with this problem, which is example number 9, is we're just going to underline the first 2 terms. And if you're confused with this, look at the variables and write out how many there are. There is 3 x's there, there's 2 x's here, and there's a y. So I'm not even looking at the 6's and the 4's right now. I'm just looking at the variables. So what's the most x's I can pull out of the front and out of the back? I can't take 3 out of the front and 3 out of the back, right? But can I take 2x out of the front and back? Can I take a y out of the first term and out of the second term? Can't do that. Okay, now I look at 6 and I look at 4. What's the maximum number I can divide out of both? A 2. After that part, it really is going to be pretty easy. 6 divided by 2 is 3. I need 3 x's in this first term, and I have 2. I need to attach one more. Positive 4 divided by 2 is positive 2. I need 2 x's. I already have those, but I also need a y. Attach a y. Whatever is in the second parenthesis, you're going to throw that in back, and I'm going to put a really light question mark here. Is there a number I can take times 3x and end up with a positive 3xy? So what value times 3 gives you positive 3? 1. So here's 3x, but I need 3xy. I'm missing a y. Now I have positive 3xy. Perfect. And when I distribute that, I have positive 2y squared. Perfect. Okay. They both contain 3x plus 2y. In front of the first is 2x squared. Bless you. And in front of the back is 1y. This would be my factored expression. It is equivalent or restructured given the initial expression. Okay, let's go on to the next one. Let's look at number 48. I made 48 more difficult. I took it from one of the practice problems that students struggled with. I underlined the first two, and now I have to identify what's the largest number you can factor out. If you don't identify the largest number, you won't get it right. Well, how can you do that? So let's think of all the numbers that divide into 32. And if you struggle with that, take 32 and divide it by 1. Oh, it works. So 1 and 32. 32 divided by 2. Okay, 2 and 16. You're going to see with 3 I get a decimal, I don't count it, but with 4 it works. Okay, so I've made the list. Now I want to check which one can divide into both. So 48 divided by 32, that doesn't work. 48 divided by 16, hey, that works. 32 divided by 16, hey, that works. So I'm going to factor out a 16x squared. 48 divided by 16 is 3, attach an x. 32 divided by 16 is 2, and we don't need any x's. So I just have to make sure I did this right. Here's 48x to the third. Here's 32x squared. Perfect. Write what we have in parentheses and back. What times 1x gives you a positive 1x? 1. Here's 3x. 1 times 2 is 2. Okay, what do we do next? We have a front and we have a back. They both contain 3x plus 2. In front of the first is 16x squared. In front of the back is 1. Who can tell me why this second parenthesis, or called a factor, why can't I break it down any further? There's something that's wrong. It's addition, and if it was subtraction, we could keep going. So number 11 on your test, this is now a trinomial. So I'm going to come off to the side. I cannot factor anything out of all three terms. 1 times negative 20 is negative 20, and the b value is a positive 1. So I need to come up with two terms that multiply to give you negative 20 and combine to give you a 1. So that's 5 and 4. The larger number will be positive. Multiplies to negative 20, combines to positive 1. So I'm going to write it like this. Now, in that middle section, I'm putting down a positive 5x and a negative 4x. And I'm going to go back to the factoring by grouping. Okay, they both contain an x plus 5 in front of the first and in front of the second, and I'm good. Okay, this is not on your review, but it's just like number 11. So I cannot factor anything out, and when what multiplies to give us negative 32 combines to give us negative 4. That would be 8 and 4. They're different signs. A larger number is negative. So x squared minus 8x plus 4x minus 32. Put down the first, put down the last, and then these two come from the two terms you're able to come up with. I can factor out an x. I'm left with x minus 8. I take whatever's in parentheses, write it in back. What times x is positive 4x? Positive 4. Positive 4 times 8 is negative 32. Okay, so we have a front and a back. They both contain an x minus 8 in front of the first and in front of the second. All right, so problem number 12. Again, we have a trinomial. And so with the trinomials, we make this x shape off to the side. I can't factor anything out. 15 times negative 2 is negative 30. Combines to give us a 1. This tells us different signs. Okay, different signs. And the larger number is positive. That's going to be 6 and 5. They're going to multiply and combine. So I put down the first term, I put down the last, and in the middle I write this down, plus 6 and minus 5. Now don't forget to attach an x to both. The front two, I can factor out at most a 3x, and I'm left with 5x plus 2. 15x squared plus 6x. In front of the first, what times 5x gives you a negative 5x? That would be a negative 1. So that's negative 5x and negative 2. Okay, so they both contain 5x plus 2. In front of the first is a 3x. In front of the second is a minus 1. This is what we have. Thank you for your patience. Here we go. 10 times negative 3 is negative 30. We need two numbers that combine to give us a negative 30 and add or combine to give us 13. Multiply, I should have said, to give you negative 30, combined to 13. This tells you they're different signs, and the larger one is positive. That would be 15 and 2. So 10x squared minus 3 in the middle. I'm going to write down what we have. We have a positive 15x and a negative 2x. Now, I could have put negative 2x first and positive 15x second. I could have done that to get the same final answer. I can factor out a 5x. I'm left with 2x plus 3. What times 2x gives us a negative 2x? It would be a negative 1. And it has to work for the second one as well, which it does. So the front and back both have 2x plus 3. In front of the first is a 5x. In front of the second is a minus 1. All right, so this is the problem. That is example number 13 on the review. All right, so I have a trinomial again. I cannot factor anything out of all three terms. 1 times negative 6 and positive 1. What does this mean? Two numbers that will multiply to give you negative 6 if this is factorable and combine to give you a 1. They're different signs. The larger is positive. Multiply and combine. Now, in that spot, I put a plus 3 and a minus 2. How do I know what variable or variables go behind them? It's going to be whatever is initially up here with the b. So xy and xy. All right, so I can factor out an x. I'm left with x plus 3y. And then I continue with x plus 3y. What times x gives us a negative 2xy? Negative 2y, so there's negative 2xy and negative 6y squared. Okay, they both contain an x plus 3y and an x minus 2y in front of the first and in front of the second. Let's look at this one over here. It's going to be the exact same concepts, So this is just an additional practice problem for you. And let's see, that looks like it's going to be a negative 6 and a positive 3. How could I work through this to get this answer, okay? How do we do that? So I can't factor anything out. 1 times negative 18 is negative 18. What two numbers multiply to give you negative 18 and combine to give you negative 3? They're going to be different signs. All right, that's going to be, the larger is going to be negative, so negative 6 and positive 3. Multiply and combine. So I write down this initial problem with an A and the C. In the middle, I write down, in this case, the positive 3 and the negative 6. Now, what do I attach with those numbers? I go back up to the B. So I'm going to attach an XY and an XY. Out of the front two, I can take out at most 1x, and I'm left with x plus 3y. Whatever's in parentheses, there's x squared, there's positive 3xy. Whatever's in parentheses, I rewrite in back. What value times x is negative 6xy? Negative 6y. I multiply to come up with this term. I multiply to come up with this term. So in the front and back, they both contain an x plus 3y. In front of the first is an x. In front of the second is a negative 6y. So the first thing we're going to do is we're going to choose any symbol we want. I tend to choose a star. You can use a capital U. Somebody else I've seen uses a picture of a cat. Whatever you want to do. I'm going to use star, and wherever I see an x minus 2, I'm going to replace it with star. So I have 3 star squared plus 11 star minus 4. Now, this is just a trinomial. It's the same thing we've done for the review problems 11, 12, 13, and 14. I go off to the side. 3 times negative 4 is negative 12. What two numbers multiply to give us negative 12 and combine to give us positive 11? They're different signs. The larger is positive. That would be 12 and 1. Make sure you do not have a cell phone out. Okay? Here's our next thing. I'm going to write this down. I have, I'm trying to think what to do here. What do I do next? I have 3 star squared minus 4. What goes into these two positions? Can anybody tell me? The plus 12 and the minus 1, but like something else has to go with it. The star. How? It's right here. Okay, so to these first two, what can I take out? I can factor out a 3 and a star, and I'm left with star plus 4. How does she do that? Here's 3 star squared plus 12 star. In the back, I'm going to put a star plus 4 again. I need to figure out what value times star is negative 1 star. And is that value times 4 negative 4? It sure is. So the front and the back have a star plus 4. In front of the first is 3 star. In front of the back is a minus 1. Now, I've done 80% of the work. What do I need to go back and do now? Is there a star in this initial problem? So what do I need to replace it with? Okay, so I take out the star, and I'm going to put what star is equivalent to. And star is equivalent to x minus 2. All right, so here we go. There's nothing to distribute here, so I have x minus 2 plus 4. When I combine like terms, I get x plus 2. Here I have 3x minus 6 minus 1, 3x minus 7. Times 12 is 24, okay, so I have a positive 24, and it combines to give you a positive 11. I'm only working with this trinomial. All right, so 1 and 24, that doesn't work. 2 and 12, no. 3 and 8, 3 and 8 work. 3 and 8 work. So what do? I'm only concerned with this. So 2 star squared plus 12. Now, in that middle, I'm going to put down what I have, plus 3 and plus 8. I don't care if 8 goes first or 3 goes first, but what goes behind both of them? A star. All right, what can I factor out? A star, and I'm left with 2 star plus 3. So 2 star plus 3. What times 2 star gives you a positive 8 star? Plus 4. So here's 8 star, and here's plus 12. They both contain 2 star plus 3. In front of the first is star, in front of the back is a 4. What have I forgotten? The 2. And now I can't stop here because really what was star? Look up to the beginning. What was star equal to? X plus 1. So I'm going to go slowly back through this. Okay, x plus 1 is going to replace star. All right, so there's nothing I can do with the 2. Now I'm going to distribute really quietly. Go 2x plus 2 plus 3. Okay, this is 2x plus 5. This is x plus 5.